Hi, welcome back. Let's talk about another way to structure our codes with modules. Let's say I have a really nice function. I take this one we've been using to sum two values a and b, and I save it as a file, and I give it a name, mymath.py. Okay? So let's say I did this yesterday. I restarted my computer, and now today I don't want to type again my function, and I want to use it in the code I'll be writing today. So in my new Colab notebook, I start a session and I import my math. So I import my module with the name without the py extension, and then I can call my function prepending the module's name. So mymath.mysum, and then the arguments, and it does as expected. Now, there are several import styles, and you will see all of them, basically, as you look at Python code. So one way is, let's say your module name is something long, and so you can give it a shorthand name. So import mymath as mm, and now you can call your function prepended by mm. Instead of mymath.mysum is mm.mysum. You can also just import not your entire module, but just one function from the module, saying from module name, mymath, import function or comma list of functions. There's another way to import functions from your modules, and this is using star. From my module name, import star, and it imports all functions and other things from your module. And as you see, it's the same output, but you shouldn't really use import star because it can bring problems when you're importing. Say you do import star from two different modules and they have common functions. So depending on the order of the import star, your code will be using the function from the last import star. And this can be quite confusing, and I'm sure there's other ways it can go wrong. So always be explicit and specify here np was a shorthand import from numpy, and here from matplotlib. So instead of saying array or plot, always prepend with the module name. Okay, so now let's talk about in-place operations, which you also see in other languages. So we define a variable, let's say counter, has value 100, and we want to add 10 to 100. And we could say counter equals counter plus 10, but by using the plus sign before the assignment, the equal sign, we are doing the same, and it's much shorter. So defining 100 and then plus equal 10 will give you 110. Okay, let's talk about classes, which is another way that we can use to organize and structure our code. And perhaps the best way is to give an example by creating a class called AnimeNeuron. A class is a template for objects of type AnimeNeuron. So we start with this initialization code that we use a definition, just like for a function, underscore init. Then we give the arguments to our class. So it can receive an argument called spikes that starts with value 0. And we define here an attribute, which is the number of spikes, that we assign the argument spikes, which if it was not provided, then it defaults to 0, and so we have 0 here. And we can define functions inside the class, which are our methods. And here I define the spike method that once it's called, it increases the spikes attribute by 1 unit. So this is how we instantiate an object from the class AnimeNeuron. So this variable, my neuron, will be of type AnimeNeuron. And then we can query the values of our attributes. So here, the number of spikes that that my neuron has, which is 0, because I didn't provide any spike value here, initial spike value, then I can use its methods, but we only had one, which is we would make the neuron spike. And then if we query again, what is the value of the attribute spikes, then it increases by 1 unit, because this is what method spike does. So let's look back at the code. In our initialization, we specified that we could receive a starting value of spikes, which we haven't used in our example. This starting value, that defaults to 0, gets assigned to our attribute spikes, self.spikes, and we define the method that increases our spike attribute by 1 unit. But we've seen this before. Recall when we've initiated our NumPy array, 2D NumPy array, we then use the attribute shape to query the shape of the NumPy array. And actually in Python, all variables are objects. So let's take this and go to exercise 7 in the Colab notebook and practice using classes.